Good evening, my mathematical minions and minionettes. Well, tonight we re-examine triangle congruence and we take a step further and we go, is there a faster way? You know, up to this point, we've been proving that triangles are congruent, but it's been a very time-consuming process. We've got two things we've got to prove. First of all, corresponding sides have to be congruent. So given these two triangles here at the bottom, we would have to prove that this side and this side are congruent. And then the second sides are congruent. And then finally, the third sides are congruent. Well, that's not all. Now that we've done the sides, we'd have to prove that the angles are congruent as well. So this angle corresponds with this one. Those two are congruent. These two corresponding angles are also congruent. And finally, the third angles are congruent. So we have to prove not only corresponding sides are all congruent, but the corresponding angles are congruent. So it can be done, but there has to be a faster way. In this age of technology that we live in today, everything can be done faster. So is there a faster way for triangle congruence? And the answer is yes. Yes, there is. So we're going to examine tonight two ways that we can prove triangle congruence, two shortcuts, if we may, as to proving congruence. So the first one is side, side, side. So side, 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 that we will abbreviate as SSS. Now, side, 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 it works like this. We're going to turn around and please excuse these two triangles. They are just rough. They're definitely not drawn to scale here. But side, side, side says that if we can prove that the corresponding sides of two triangles, that all three sides are congruent to each other, then that's enough. We don't have to mess with the angles. That it's enough if we have those three sides. Well, let's just think about it, okay? If we set off and we start off here with a segment, and let's turn around and let's examine here and let's take a look. Let's get us a different segment right here. So if we have this segment length up here, and let's just give me a second here. There we go. Find the tools that I need. So we've got these two segments that are sitting here with this length. Is there any way? Is there any? And we've got them, and there are set lengths. So let's say we've got two sets here, and they're identical to each other. If we know with these two set lengths, is there more than one way that we can connect these two with different lengths? I mean, if we spread them apart, is that going to happen? No. I mean, if we spread these two things apart further on, whatever that length is right there, if we've got three set lengths, they're only going to fit together one way. So if we look at them, so side, 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 that is a good shortcut for us, and it's the first way. And we'll look at proving some of these things later, but a little bit of common sense here. And the second one is called side, angle, side. And it says that if we are given two triangles, and here again, please excuse my rough triangles that I'm drawing here, just freehand sketches that we look at. If we have two triangles, if we can prove that two of the corresponding sides are congruent to each other, and notice where this angle is in side, angle, side. This angle is between them, so it has to be the angle in between. If we can prove that we have two side lengths and the angle in between them, if they are congruent, then there has to be, there's no other way that those triangles can be formed but for those triangles to be congruent. So that's looking at that one, and we'll abbreviate that one as SAS, as side, angle, side. Now, the question comes in, okay, well, if side, side, side works and side, angle, side works, does angle, angle, angle work? Is there a way for us to turn around and take just given three angles and make, does that mean that triangles will always be congruent if we've got three sets of angles? Well, if we look back to what we had about similar triangles, if we go back to what we had with similar triangles going back a little ways, let's turn around and let's take us a triangle. Let's put us one triangle here and a matching triangle along with it. Let's take a look at these. Hopefully you can agree that these two triangles are exactly the same as far as the angles. If we look at these angles, and we could pick these things up and we could stack them on top of each other. Obviously, each of these angles for this one, these angles match up. If you know right there, those angles match up. What if I stack it up on top? Well, yes, you can see there's no overlap. What if I come down here to the bottom? Obviously, those three angles are all three the same, but you can take a look at those things and see, obviously, there is no way that they're congruent triangles. They are similar triangles, but they are definitely not congruent. And if you remember in similarity, we had that one triangle similarity. We could use angle, angle, and we said we didn't have to have that third angle. We didn't necessarily have to have angle, angle, angle. Two angles was enough. that proves that they're similar. But does angle, angle, angle work as far as congruence? And the answer is absolutely not. Absolutely not. So let's take a look here at the bottom here, and let's look at these triangles, and let's see if we have enough to prove that these triangles are congruent to each other. So the first one, look at these first two pair here. And you might want to just go ahead and hit pause right now and go ahead and see if you can prove if there's enough for these triangles to be congruent. If so, give a reason. Remember, we've got two reasons, side, side, side right now, or side, angle, side. So hit pause and we'll come back. All right, well, hopefully you've taken a look at this and you've got these triangles right here. When you see the first two, are they congruent? Well, we've got this side congruent to this side, a second corresponding congruent, and a third. Yes, they are. Why? This is definitely side, side, side. So let's look at the second one. Well, we've got three congruent marks here, three congruent marks here. Those two will work. Two congruent, two congruent. Those two are enough. Well, we've got two sides. Oh, do we have anything else? Hey, check out right here. Vertical angles are congruent. So these two work. This is side, angle, side. So look at this one. Now we've got a congruent mark here, congruent mark here. We've got the angles are congruent and they share a common side. So this one would be side, angle, side as well. Going down to the bottom. Well, we've got angle congruent, another angle congruent, a third angle congruent. Well, we've got three angles congruent. Is there enough? No, this one does not work. Okay, so let's look here. We've got a side up, we've got this side, we've got an angle, and then they share this same side. Well, so is that side, angle, side? Look up here. We've got a side, an angle, and a side. All right, looks good here. What do we have down here? Side, angle. Oh, no, the side's in the wrong place. This does not work for side, angle, side. So maybe something we'll learn on later down the road will help. But as for right now, no, those are not congruent. All right, let's look at here. Well, we've got these two angles are congruent. Hey, they share a common side. Anything else? Ooh, no parallel lines, no marks like that right there. No, it's not enough. So in this case, we do not have congruent triangles there as well. All right, so it kind of leads us into this point. Let's go and let's take a look at some proofs. Let's go ahead and do a couple of proofs right here, and let's figure out all these triangles congruent. So given right here, H is the midpoint of GT. H is the midpoint of GT. Unfortunately, nothing I can draw in my diagram here. HR is congruent to IR. So HR, if I can get my pen to work this evening, HR is congruent to IR. So we've got that. So let's start with our statement. What is the reason? Well, that's given. They give us that one. That's kind of nice right there. Now, we always know that anytime we're given something, if there's something we can define, something we can explain, we have to do it. So what does it mean that H is the midpoint of GT? Well, that means that segment GH is congruent to segment HT. Now we've got these two. Those two are congruent. What's the reason for that? Well, that is the definition of a midpoint. That's the definition of a midpoint. So there's our second one right there. We need something else. Hey, look here. It's always our friendly neighborhood vertical angles. Friendly neighborhood vertical angles. So let's go ahead and say that angle IHG is congruent to angle THR. Remember, the only major important thing there is that our vertex is in the right place. Why? Because vertical angles are congruent. You have that wonderful postulate that says all vertical angles are congruent. Well, from there, we can now say that triangle GHI is congruent to triangle THR by what reason? By side, angle, side. So there we go. All right, so let's jump in here and let's take a look at this second one. You might want to go ahead and hit pause, see if you can try that one and see if you can figure it out. By the way, let me go ahead and fill this. Why are these two triangles congruent? And we said it would have to be by side, angle, side. So go ahead and hit pause, give this one a shot, and we'll come back in a moment. All right, well, welcome back. Hopefully you've got this thing figured out. Let's look. Triangle ACB is an isosceles triangle with base AB. Important information, unfortunately nothing I can label right now. CP is an angle bisector of angle ACB. Here again, great piece of information. Nothing I can label on the figure yet. We don't have any statements, but we'll go from there. So first they give us a given statement. So go from there. Let's define something. So let's start with this first one. Triangle ACB is an isosceles triangle with base segment AB. So AB down here is our base. This is our base of this isosceles. Well, what does that mean it's isosceles? Well, we can say that AC is congruent to CB. So segment AC is congruent to segment CB. Why? Well, that's the definition of an isosceles triangle. Definition of isosceles triangle. That's what it means to be an isosceles triangle. Well, they also tell us that CP is an angle bisector of angle ACP. Well, then that means that angle 1 here has to be congruent to angle 2. So I'm going to say angle 1 is congruent to angle 2. What's the reason? Well, that's the definition of an angle bisector. That's what it means to be an angle bisector. All right, well, looking at this. Well, we've got a side and an angle. Oh, side and an angle. If we had one more side, we would have it. Do we? Oh, of course we do. CP there. Thank goodness they share a side. CP is congruent to CP. What is that? That is the wonderful mirror, mirror on the wall, the wonderful reflexive property. Reflexive property. So now that we have that, let's take a look. What do we have? We've got a side, an angle, and a side. So are these triangles congruent? Absolutely they are, by side, angle, side. So triangle ACP is congruent. We knew it was. We just had to prove it. To triangle BCP. By what reason? By shortcut side, angle, side. So fabulous job right there. All right. So let's take a look here. Now, properties of isosceles triangles. As you see here, yes, obviously isosceles triangles are cool. The theorem says if a line bisects the vertex angle of an isosceles triangle, so if a line bisects the vertex angle, okay, then what do you think about it? If a line bisects the vertex angle of an isosceles triangle, then, I'm giving you a second, what do you think? Well, of course, then it separates the triangle into two congruent triangles. Ooh, let's hope if I can spell tonight. Then it separates, S-E-P-A-R-A-T-E-S, then it separates it into two congruent triangles. So, if we said, if AC is congruent to CB, that's what it means, okay? And, it's isosceles, and angle 1 is congruent to angle 2, then what we have is we have two congruent triangles, okay? Because, why? Because of course, of side, angle, side. Because of side, angle, side, then we have two congruent triangles. So those two are congruent to each other. So as we turn around, we do this, look at this. Let's go ahead and do a little bit of algebra review. I know we've been doing some lately, and we've been looking at some. Let's go ahead and practice these together. So once you go ahead and hit pause on this one, see if you can fill out this algebra review, and we will be right back. Time is running short. Let's take a look here. So the first one, solve for us. We do distributive property. We do negative 2 times 3x and negative 2 times negative 8. So we get 5 minus 6x plus 8 equals negative 7. Well, we combine some like terms. Combine this 5 and this 8 gives us 13. Now we subtract 13 from both sides. So that gives us a negative 30. Divide both sides by negative 6, and we get x equals 5. So let's look at the second solved one. Here, well, we've got two proportions, two sets of equal ratios. So we cross multiply. 4 times 2x gives us 8x. 4 times negative 1 is negative 4. And 6 times x equals 6. So from here, we'll turn around, and I went ahead and subtracted 8x from both sides. When I did, I got negative 4 equals negative 2x. So divide both sides by negative 2, and we get a positive 4. Man, I almost let that one slip away from me. So we get an x equals a positive 2. So this next one, we notice we've got a graph, it is y equals negative x. Well, that's the same thing as y equals negative 1x plus 0. We know we start at the origin, 0. Our slope is negative 1. That means we go down 1 over 1, down 1 to the right 1. So it's going down. It's a negative slope. The second graph here, well, this is the same thing as y equals 2 over 3x plus 0. Here again, it starts at the y-intercept is the origin. So we start from there. We go up 2 and to the right 3, up 2 to the right 3. So this thing is increasing at a slow pace here, less than 1. It's a little bit flatter than what our normal one is. So there's where we are. All right. So let's look at this last one. Let me take a look. There's the answers to the last two. Good luck and good night.